look at some sequences and try to determine whether they converge or diverge. So the first example we're going to look at is a sub n. Let's try that one more time. There we go. A sub n is equal to -1 to the nth power over n squared plus 1. If you want to stop the video and write out the first few terms of this for practice, that would be a good idea. Otherwise, we'll just keep going here. So I'm going to write out the first few terms just to see what might be happening here. So a sub 1, I'm going to plug 1 in for n. And I'll do this on the first couple terms, and then after that we'll kind of see, we could do this, a lot of this in our head. So we get 1 over 2. Alright, a sub 2 is going to be -1 squared, and then 2 squared plus 1, so that's going to be a positive 1 over 5. A sub 3 is going to be -1 to the third power, which is -1, and then 3 squared plus 1, which is 10. And the fourth term, we're going to get -1 to the fourth power, which is positive 1, and 4 squared plus 1 is 17. So the first four terms are -1/2, positive 1/5, -1/10, positive 1/17, and we could keep going. So just based on what we're seeing there, what do you think? Is this going to converge or diverge? Well, if we look at the numerator, it's basically going back and forth between 1 and -1. If we look at the denominator, it's getting bigger, and it's going to continue to get bigger. And so therefore, we're going to be approaching 0. So I think this is going to converge to 0. Let's go ahead and take a look at what that graph might look like. Here's the first few terms, and we can see from the graph that it is converging to 0. Alright, let's try another one here. Let's say we want to do, I'm going to do a little bit of different notation here. Let's do a sub n plus 1 equals -2 times a sub n, and a sub 1 equals 1. Alright, so this is written as a recurrence relation, or an implicit formula. So this tells us we know that our first term is 1, and we know our second term is -2 times the term before that. -2, so this is a term, some term, the n plus 1th term. The nth term would be the term right before the n plus 1 term. So it tells you, this says you take -2 times the term to get the next term. So -2 times 1 is -2. Then the third term, I'm going to get that by taking -2 times the term before that, which is also -2. That multiplies to be 4. The fourth term is going to be the third term times -2, so that is -8. Alright, what's happening with this sequence here? That looks like it's diverging. It's getting big, the absolute value is getting big, positive, negative, and that graph would look like that. Okay, so we definitely have a diverging situation there. Those dots are not going to converge on something. Let's look at a real-life type example of developing a sequence. A basketball is tossed straight up in the air, reaches a high point, and falls to the floor. Each time the ball bounces on the floor, it rebounds to 0.8 of its previous height. Let h sub n be the high point after the nth bounce, with the initial height being 20 feet. Find a recurrence relation and an explicit formula for the sequence h sub n. What is the high point after the 20th bounce, and is there a limit of the sequence? So something that's a little bit different here is we have h sub 0 equals 20. So that means our first term in our sequence we're saying is 20, and we're letting that be h sub 0. So basically we're saying this is when n equals 0. So h sub 1 would be after the first bounce, because we're saying it was tossed up into the air and reached a height of 20 feet. So this would be when n equals 1. And it's going to be 0.8 of its previous height. So basically we need to take 20 times 0.8. And I believe that would be 16. 80% of 20, that sounds right. All right, then h2 is the height after the second bounce when n equals 2. So we need to take 16 times 0.8, which is 12.8. Let's see, how many of these do we need to do? Let's do one more. So h3, when n equals 3, we'll take 12.8 times 0.8, and we get 10.24. And that would be the height after the third bounce. And this would continue. All right, so find a recurrence relation and an explicit formula. So we're trying to find two different formulas here for h sub n. Which one do you want to do first? Let's do the explicit formula first. Again, you might want to pause the video and see if you can come up with it. It's kind of nice to do and then start the video. All right, so if we think about how we got these values here, we basically took each term and we multiplied it by 0.8, starting with 20. So I might say h sub n, I'm going to start at 20, and then I'm going to multiply by 0.8 each time to the nth power. Now I want my first term to come out to be 20, which would mean I would need to start at n equals 0, so I would want to specify that somewhere in here. N equals 0, 1, 2, etc., like that. All right, if I want to write a recurrence relation or an implicit formula, oops, that's not part B. Let's get rid of that. It's still on part A. I'll call it implicit, all right? That's the same as a recurrence relation. Same thing. We would say what our first term is. So we'll say h sub 0 is our first term in our sequence, is 20. And then we would say, okay, how do I get the n plus first term? Well, I take the term before that and I multiply it by 0.8. So these two pieces of information could also generate this sequence over here. So using either of these guys, either of these formulas, we could answer part B, what is the high point after the 20th bounce? But one of them is actually much easier. You'll see with the implicit formula, if you wanted to find the height after the 20th bounce, you'd literally have to keep typing into your calculator times 0.8 times 0.8 times 0.8. Where if I use the explicit formula, after the 20th bounce, it's going to be 20 times 0.8 to the 20th power, whatever that is. Let's see what it is. 20 times 0.8 to the 20. I bet it's not too much. 0.23 feet. About 4 inches off the ground. Do we think there's a limit of this sequence? Do we think that the sequence will converge or diverge? Well, hopefully you see that it's going to converge, and it's going to converge to 0, right? The height of that ball is going to eventually reach 0. Now, sometimes you'll see a trick question here where it asks you for the total distance traveled, the total distance that the ball travels after so many bounces. Like, let's say, well, here, I think in this situation, this is supposed to be a dude here, and he's throwing the ball up in the air. Sometimes it reached a height of 20. So, and then this is the first bounce right here. So this is like n equals 0, the height after no bounces. This is n equals 1, the height after one bounce, and here's where it's bouncing. So if I wanted to say the total distance that the ball traveled, sorry, bad spelling. Total distance the ball traveled after, I don't know, 3 bounces or something, then you have to account for the ball going up and the ball going down. So you could say, well, it went up 20, then it went down 20, then it went up 16, then it went down 16, and just keep going until you get your 3 bounces worth. Or you could do your 3 bounces, your 3 heights, actually with 3 bounces. Let's see, 1, 2, 3. yeah, we could, you have to see how the question is worded. Do I want to keep going here? Or I think I would probably say the question would say, what's the total distance traveled when the ball hits the floor for the third time? So we're not going to keep going. We're just going to add up to here. So then we would add up 12.8, and then we could just double this for the up and the down. So you could do it that way as well. But you got to watch out for that. Now, if it said the ball was dropped from a height of 20 feet, and then it bounced and came back up, then you wouldn't do 20 twice. So you got to kind of be careful with those. They can just be a little tricky in how they're worded. Now, if we wanted to look at a graph of this sequence, it would look like this. This is the height after each bounce, and we can see after a certain number of bounces, definitely close to 0. And the physics of the situation, the ball's going to actually hit 0 at some point and quit bouncing. Theoretically, this never gets to 0. Right? This, I could put n to be 1,000,000 and it's still going to be above 0, but we know physically that ball's going to stop bouncing at some point. Alright, so in the next video we're going to talk about series, and convergence and divergence of series is going to be a big topic of Calc 3.